Hi there, welcome back to the formulaic approach. Now in this video we are going to be covering series and sequence and series. Alright, but before we get into it, in the meantime I'd like to introduce you to a particular textbook or introduce a particular textbook to you, whichever one. So I just got mine. It's a very good textbook. It's called Foundation Mathematics. It's one thing I like about the book is its affordability and the fact that it covers many questions from national and international exams, UNE, WAEC, IGCSE, CBSE, Olympiad Mathematics, American Mathematics competition. So, and it's a teach yourself maths textbook. So you cannot, this is one of the assets you need to acing JAMB, exactly. So for those of you that are struggling with maths in physics and maths itself, do well to get the textbook. It's very affordable. Just reach out to me on that number and I'll send the number of the writer to you, okay? And you will reach out to him to get the textbook. All right, but in the meantime, we are going to start already. So what is a sequence? What comes to mind? Sequence is basically an ordered set of numbers. I mean, even in the natural world, we see an organized system of things so that follow each other in an ordered manner. So we call it a sequence. Okay, so the same way mathematics sequence, primarily about number, is basically an ordered list of numbers where each next term, each successive term can be gotten from a previous one by a simple operation or logic. Exactly. So that's what sequence is. And series is basically the sum of many of a sequence. So summation of a given number of sequence is called series. And there are two types of series. We have the finite and the infinite series. So finite series has a limit, right? While infinite is forever, right? To infinity. Is that okay? So, but primarily let's start with sequence under AP. So now we split sequence and series into AP and GP based on this. If the operation between them, now keep in mind that the method I'm going to teach you in this video is the method you should use to solve questions. It's very easy. My method is not the best in the world, but this one helps. It's going to help you to be able to solve a lot of questions. So trust me, okay? Now for AP under series and sequence is just any sequence or any set of numbers like that, the ordered numbers like that, that the operation that is used there is addition and subtraction. Then that is AP, arithmetic progression. GP is the one that the operation that is used to form that sequence or operate that series is multiplication and division. That is GP. Is that clear? So now let me show you how the formulas are derived, then we'll use them and how to use them. Now keep in mind the method of deriving too is very important to understand. I promise you're going to help you to understand how to solve questions as well. Exactly. So now listen, let's begin with arithmetic progression. Arithmetic progression. Now, in arithmetic progression, we could have something that looks like this. We could have a sequence like this. If I have a sequence like this, for example, I have 2 4s. No, let me use something that is not so obvious. I don't want the same set of numbers. So let's say I have something like, okay, let's use 2, and this time let's use 5, 8, 11, 14, 17, 21, 20, etc. Now, if I have this set of numbers, keep in mind that every number here is called a term. So this one that is appearing first will be called the first term. This one will be called the second term, third term, fourth term, fifth, like that, and so on. Is that clear? All right. Now the first term, I'm going to call it T1. You can already see that the T1 here is 2. Okay? All right. Now the second term, do you notice that between this term 1, term 2, term 3, term 4, term 5, and blah, 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 like that, there is something that is common. There is something that is attributive of them. And if you look closely, you will see that it's basically 3. There's a sort of like 3 happening here. What is 3 doing here? You see that 3 is adding to an initial term to get the next successive term. Does that make sense? So 2 is being added onto 3, or 3 is being added onto 2 to give 5. 5 is being added onto 3 to give 5. Or 3 is being added into 5 to give 8, rather. 3 is being added into 8 to give 11. Does that make sense? So we can already say that that guy, you will see here that to get this T2 is actually 5. And how did we get 5? It was actually the first term plus 3, this particular 3, and it gave us 5. Make sense? Now, how about T3? You would notice that T3 is actually the same. Now, T3 is like saying 5 plus 8. Right, 5 plus 3, right? This T3 here. T3 is 8. So it's like saying this guy plus that same 3, right? 5 plus 3. But of course, you know that this 5 was gotten from 2 plus 3. This is 5, right? Then plus this 3 again. That was what gave us 8. And let's try it. 2 plus 3, 5 plus 3, 8. Do you see that? Okay, we're getting somewhere. Just stick with me. Now for the T4, term 4, it's like saying 2 plus what? This term 4, how did we get it? It's like saying this initial term, which is 8 plus another 3, gave 11, right? But this 8 came from 2 plus 3 plus 3. Then this 8 here, right? Then plus this 3. That's what will give us 11. Are you following? Now let's stop at term 5 so that you see what I'm saying well now. At term 5, this is term 5 here. 1, 2, 3, 4, 5. At term 5, we have 14. Now 14 is basically 11 plus 3. 11 plus 3. That is the fourth term plus 3. Now 11 plus 3. 11 is gotten from 2 plus 3 plus 3 plus 3, isn't it? Then plus this 3. That's how we'll get our term 5, which is what? 14. Good. Now using this same logic, we can get an expression for any particular sequence that we are given. So because it is such that you notice that something is repeating. Okay, there is something that looks what's it called now? It's quite ordinal here, but there's something that looks that is common here that keeps appearing. Okay, so now let's call the first term. Let's call it A. Let's say we don't know the first term, we'll call it A. According to this expression, we will, to get T2, we will add the first term to a particular 3, right? If we call the first term A, for example, we don't know it. To get the second term, we'll add that A to a particular 3. But this 3 is not, because 3 is not going to be the only thing that we can add to make any sequence. What if it was 4, 4, 4, 4, 4, 4 that was being added? So because it is that number that is being added, let's call that number, let's call it D. Okay, let's call it D. So then T3, if we want to get T3 will basically be that first term, which was 2 here, let's call it A here, plus the same guy D, but twice, we are adding it twice. Is that clear? Then T4 is actually A, the first guy, plus D, plus D, plus D again. Make sense? Then T5 is actually A, plus D, plus D, plus D, A plus 1, 2, 3, 4. A plus D. Okay. By the time we come out with an operation, with an expression, we have T1 is A, right? Plus no D, right? There is no D here, right? T2 is A plus D. Nothing can, we can't go any further from there. Then T3 is actually A plus 2D, okay? T4 is A plus 3D, okay? T5, I'm noticing something right here. T5 is A plus 4D. It seems to me as though if I take a particular 4, a particular number, the number of D I will add to the first term is just one less than that number. Let me see. It means that if I wanted to get C6, it will basically be what? A plus 5D. Following that, T1 was A plus no D. T2 is now A plus 1D. T3 is now A plus 2D. T4 A plus 3D. T5 A plus 4D. T6 A plus 5D. T7 A plus 6D. T8 A plus 7D. Then. Do you understand now? So that's the way it's going, right? So it means that what if we are not giving the term? So it means we are looking for a particular number of term, then it will be A plus that number of term minus 1. We'll remove 1 from it. Then we will now multiply it by D. Is that clear? So that is how the formula is being generated. All right, I don't know why I'm laughing. Okay, so that's how to use the formula. Okay, now let me now teach you a strategy. If you are asked to solve a question and the question begins like the first term of a this is this, just go right. First term A is blah blah blah, whatever you're giving. If it says the 19th term of an AP is this, if it says the 19th term of an AP is this, just go like this. 19th term of what? T19, right? What is T19? T19 is A plus 18D. Is that guy. Is that okay? T19 will be A plus 18D. T44 will be what? A plus 43D. So if it says T90, if I say the 100th term of an AP is what? You say 100th term is A plus 99D is that thing you are given. You see, this method is faster. Is that clear? All right. Now let me write some questions on the board and then we'll solve the, oh no. Let me show you how to work out the series for GP. Now, what we want to get the series for GP, the series for AP rather, the series. I'm going to show you how to solve questions, okay? I'll solve questions for you, then I'll show you how to get solve questions. Now, the sum of AP now, that is this AP series, right? Now, how do you get an AP series? You see, this method, this mathematical or numeric trick was gotten by one small boy. So it's in, I think in the 19th century, okay? So, and I think, I'll just leave the story, okay? Leave the story. Let me show you something. Let me show you something first. If I ask you to add the following numbers, 1, 2, 3, 4, 5. Now, what is the sum of this thing? It's very simple. All you need to do is just take 1 plus 2 is 3, 6, 3 plus 3 is 6, 10, 15, right? Now, what if I show you that? Now, what if it's very, very longer than this? Now, what is the trick to doing that? Now, there's one thing you can do, a trick, is to bring this 5, rewrite it here, then it goes like 5, 4, 3, 2, 1. If you will notice that each guy you add is the same, right? All right. So since it's the same, you will add up this one and this one. Is that clear? You will add this guy and this guy, right? So when you add it, what do you get? You're going to get 6, right? Now you will now multiply that 6, that number. You will add up this first guy and the next guy, more like add this one and the last one. You get 6. Now you now multiply it by how many expressions you have there. How many expressions do you have there? That's because, listen, it's very simple. It's a very simple idea. Notice that if I add this guy together, it will give me 6. This guy together, 6. This guy together, 6. This guy together, 6. This guy together, 6, right? How many times did 6 appear? That 6 appeared 1, 2, 3, 4, 5. 5 times. Then divide it by 2 because I made it into 2 sections like that. So I'm dividing by 2. Here 1, here 3. And we'll get what? 15. So somebody might say, whoa, does it work for every other guy? Okay, let's try it for our series here. Now you have 2, 5, 8, 11, 14. Let's stop here. Let's say we want to find this series. Now if you want to find this series, watch. If you bring this guy here, 14, 11, 8, 5, 2. Now, if you add up each guy, what will you get? Notice, this plus this 16, this plus this 16. Okay, still the same. Good. So since it's still the same, it means we have not made a mistake. That's 16 plus, how many times does 16 appears? 1, 2, 3, 4, 5. I don't want us to use 5. I don't want us to use 5. Let us increase it to like 70. In fact, let's do the entire thing there. Let's do the entire thing there, so that you not say it's 5 by using, okay? So 20, 20, 17, 14, 11, 14, 11. What is this now? 8, 5, and 2. By the time you add each up, you see to give you 22, right? So it means 22 is appearing how many times? 22 is appearing 1, 2, 3, 4, 5, 6, 7 times. So 7 times. So divided by the two sections, here 1, here 11. So we have 11 times 7 is what? 77. And by the time you add this all up, it's going to give you 77. Let's try it. This 37 plus this 25. 37 plus 25. So that's 2, 6. 62 plus 13, 15. 15 here. So that's 77. Do you see that? So that trick works, right? So it is this numeric trick that we will use. Now, the guy that invented it was a small kid. I think it was used for him as a punishment to add up all the first prime numbers or all the odd numbers between 1 and 100. So and he invented this. So that's just by the way. Let me now show you the use of this trick. Now look at the use of this trick. The use of this number is if I have a sequence. So you see that for this, my sequence that I gave here, to get my first term is going to be A, right? My second term is going to be A plus D, isn't it? My next term is going to be A plus 2D. Afterwards, I will have A plus 3D. Afterwards, I will have A plus 4D. Afterwards, I will have A plus 5D. Afterwards, I will keep having A plus blah 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 until I have A plus n minus 1D. Does this make sense? Good, good. Now, this is what we will now do. We will now reverse this thing. Exactly the same way, basically by adding the first term and the last term here. So notice that this formula we got is also called formula for last term. So you can say last term is equal to A plus n minus 1D, because the last term is like the last term, but we know the position, okay? That's the n. That position is the n. So the first term minus last term. So we want to get the sum of this thing. Let's call it S. Okay, sum of this sequence, maybe Sn, is going to be the first term, that is A here, plus the same trick, right? If I were to arrange this one under it like this, it will be the first term plus the last term, which is A there. The last term there is A plus n minus 1D, isn't it? This is the last term. Then first divided by 2. That's the way the trick works, right? So S sub n becomes A plus n minus 1D over 2. So S sub n becomes A plus A, 2A plus n minus 1D all over 2. Is this clear? So if this is the case, sorry, there's something I missed out. A plus the first term plus the last term. For last term, the formula for last term for sum is Sn equal to n over 2 bracket 2a plus n minus 1d n over 2. Okay, so I'm missing out the n. How did that come in? A plus, please let me quickly derive this again. Let me try and derive it again. Okay, I'm sorry. You remember that in the trick, I have to add the number, then multiply by how many times it appears. Okay? You remember that in the trick, if I have 1, 2, 3, 4, 5, and I did 5 plus 1, it will give you 6 times. How many times does it appear? 5 times. Is that okay? So this one too will appear n times. Is that clear? It has to multiply by n multiplied by n. Do you understand now? So I forgot this. I'm very sorry. Okay, so if that's the case, then we are good to go now. So that the formula, thank God I remembered that. So Sn is now equal to n over n. By the time you bring this guy forward, it becomes n over 2 brackets 2a plus n minus 1d. And this becomes the formula for sum of a GP. Now, I'm going to be solving some questions now. Let me write some questions on the board and then we're going to solve together. All right, so now that we've learned of the formulas, let us first solve these 5 questions. Then we'll move to GP, after which we'll now solve different questions, many more questions, okay? So one of the purposes of this video is so that you know how to attempt questions. All right, so let's solve the first 5 here. And the first one says that find the 10th term and the sum of the first 10 terms in the following sequence. So there are 2 questions per question there. So one thing you must first know is also that I didn't show you is that the common difference, D is the common difference, okay? So A is what we call the first term, you get it? And D is what is called the common difference. D is what is called the common difference. So in those expressions that we obtained, this guy, N is the number of terms, A is the first term, D is the common difference. Now then, one thing you should know is that the way to get the common difference is basically, you remember our sequence that I gave you, 2, 5, 8, 11, 10, something. To get the common difference, simply subtract to get the common difference, D is basically T2 minus T1 or T3 minus T2. You get exactly the same answer, right? Or T4 minus T3. Like that. So just subtract any 2 successive terms. And it should be the one ahead minus the one before. So this minus this minus this is the same. Exactly. So that's how to generate the common difference. Now let's solve that question. Find the 10th term and the sum of the first. So the 10th term is T10, right? So that's what we're looking for. And the sum of the first 100. So let's leave the sum yet first. The sequence given to us first is 1 over 4, 3 over 4, 5 over 4, 7 over 4. Now, the first thing we need here is the first term. What's the first term here? Is 1 over 4. That's the first guy you are seeing here, 1 over 4. Then what about D, the common difference? Remember I told you just subtract the one in front minus the one at the back, the one in front minus the one at the back, like that. Okay, the same way here, we just pick any 2. I like these 2 in the middle, so I like to use them because they look fine. So it will be 5 over 4 minus 3 over 4. Minus 3 over 4. So D therefore becomes LCM is 4. So that is 5 minus 2 minus 3, isn't it? So that becomes 2 over 4, here 1, here 2. Is that clear? What I basically did was take LCM, okay? So in case you are lacking these basic skills, that's why I told you to get that textbook, okay? I mean, does that. So D is what? 1 over 2, we've gotten that. So let's now supply it into the equation. Now, you remember, do you know that I don't even need this equation to solve? Because I know if I'm looking for T10, my formula will become what? A plus 9D, from what we learned here, isn't it? So here I can easily say that T10 is A plus 9D according to what I just said, and first term is 1 over 4. So I have 1 over 4 plus 9 times D is 1 over 2. So that's 1 over 2. So I have 9 over 2 equals 1 over 4 plus 9 over 2. What is the LCM? 4. Here 1 times 1 plus 2 and 4 is 2 times 9 is 18. So the answer is 19 over 4. And that will be our T10. 19 over 4. Or 6 whole number, 4 whole number, 3 over 4. Alright. Well, to present in the form in which you were given, this will be the answer. Now, what if we wanted to get the sum? Let me put the sum here, very easy. So the sum, remember that sum is n over 2 into bracket 2a plus n minus 1d. Now, there's something you should also notice in this formula. It is the fact that this formula is also there. That's here, right? Okay, so I can say that the sum, the formula is also n over 2, open bracket 2 into bracket a, which is, you know that this is a, right? So it will be a plus a, isn't it? 2a is a plus a. So that will be a plus, this becomes a plus this. So a plus this is, from here, is going to be our last term, right? So a plus last term. So this formula can also be written that way. Is that clear? All right. So the sum, therefore, for this case becomes n over 2. How many terms do we have there? We have, it says you find the sum of the first term. So that will be S10. S10 will be equal to n, which is 10 over 2, open brackets. We are going to use this formula, not this, because we don't know the last term, okay? So a plus, 2 times a, that is 2 times, what is our a? 1 over 4. So what's the clean this question? 2 times 1 over 4, then plus n, which is 10. Just follow me, you'll get it. Minus 1 times d. What is d? 1 over 2. Is that clear? So that is that. So that S10 therefore becomes, S10 will become here 1, here 5. So 5 into bracket, here 1, here 2. 1 over 2 here, right? Plus 9 times 1 over 2 again. That is 9 over 2. You can already see that, right? Because this is 9 times half. That is 9 over 2. So you then have 5. This becomes, S10 becomes 5 into bracket. LCM is 2, right? 1 plus 9. So that S10 becomes 5 into bracket. 1 plus 9 is 10. So we have 10 over 2. This is 5 again. So that 5 times 5 is what? 25. So S10 is what? 25. That's the answer. Is that clear? So that's for the first guy there. How about the second guy there? The second guy there. So this is a finite series, okay? We know the number of terms we have to find. So it's a finite series. So look at this now. The B part says for minus 10, minus 5, 0, 5 sequence, we should find the 10th term. So first we need our A. Our A here is the first term we are seeing here, which is minus 10, isn't it? Then what will be the common difference? I told you just take any 2 and subtract, right? So I'm taking the one, make sure it's the one ahead minus the one before it. So that will be minus 5 minus 10. Keep that in mind. This guy minus this guy. So D now becomes minus 5. You know, I could also pick 0 minus 5, okay? So it's the same. You'll get the same answer. Minus times minus plus 10. So D becomes 5. Is that clear? By the time you do this, you rearrange 10 minus 5, that's 5. Right, so we have gotten A and D. So we need the 10th term. Remember again, that T10 will be what? A plus 9D. Well, for someone that might be thinking, how am I getting it? If you use that formula, that Tn is equal to A plus n minus 1D, then T10 equal to A plus n, that is 10 minus 1D, isn't it? So T10 will be equal to A plus 9D. This is why it was not necessary to go through this again now. Alright, so we'll bring this here. That T10 is equal to A. What is our A? minus 10 plus 9 into bracket, what is D? 5. So T10 therefore becomes minus 10 plus 9 times 5, 45. So that is equal to 45 minus 10, which is what? 35. And that is the answer for T10. So what we wanted to find is sum of first 10 guys. Remember that Sn is equal to n over 2 into bracket 2a plus n minus 1d, right? Let's use the formula of a plus last 10 here. Do you know how? Basically, oh, okay, we had even found T10 here, so we could just use it. Okay, it's the same. See, this answer here, we wanted to use a plus, we wanted to use S10 equals n over 2 into bracket a plus l here. You know the last term here is this guy, which is 10th term. So it will become 10 over 2, which is 5 into bracket a, which is 1 over 4, times the last term here is 19 over 4. Plus, not times, sorry, plus. So that it becomes 5 into bracket. LCM of this is 4, 1 plus 19. So that's 20 over 4. 20 over 4 is 5. 5 times 5 is also what? 25. Do you see it now? So we could use it here too. All right, but since we know that now, let's just continue. So n is still 10 over 2 into bracket 2a. That's 2 into bracket minus 10. Is that clear? I mean, there's a way I taught some of my students to do this thing. When you are taught to find sum of first 10 tenths, it will be equal to S10 equal to 5 into bracket 2a plus 4d. This will be the formula. Why? Because you can already, 90, sorry. Because you can already substitute 10 into this equation already. So you can use this directly. Is that clear? But if you don't understand, you just solve like this. Just solve your thing. So S10 therefore becomes 5 into bracket 2 times minus 10. That is minus 20 plus 9 times, what is the D? 5. 9 times 5. So we have S10 to be equal to 5 into bracket minus 20 plus 45. I hope you understand what I did here. What I did to get this expression was to put 10 here, put 10 here. To simplify the equation to this. Right. So minus 20 plus 45, that's 25. So that's 25, so that S10 becomes 125. All right. Yes, 125. So now let's go to the number 2 question. Number 2 question says that the second and sixth term are 10 and 34. You see, once I hear the second and sixth term, what is my second term? T2 is A plus D. What is sixth term? Sixth term is A plus 5D. Do you see where I solved it? Second term, A plus D. From what we got in the beginning. Sixth term, A plus 5D. They are what? 10 and 34. You see, already I've made my simultaneous equation out of it. Do you understand now? Without doing much, I've already made a simultaneous equation. Now, find the common difference, the first term, the nth term, the 100th term, and the sum of the first 100 terms. So it's very simple. Now, what you do is this. Now, looking at this, you can already bring out, let's just, what's it called now? Use elimination method. I wanted to do something else before. If we use the elimination method, same sign subtract, and then you have D minus, let's subtract equation 2 from equation 1. This minus this will give us 0. D minus this will give us minus 4D is equal to this minus this minus 24. Is that clear? 10 minus 34. So divide both sides by minus 4. Yes, 6. So that D becomes 6. So from equation 1, recall that A plus D is 10 in equation 1. So anywhere we find D, we'll put 6. So A plus 6 equal to 10. So then A must be what? Must be 4. If something plus 6 gives us 10, A must be 4 then. That thing must be 4. So we've gotten the first and second term. So we have solved question A and question B. Now let's go and solve questions C and D. Now to solve questions C and D, we have to find the nth term. So what will be the nth term? Remember that Tn is equal to A plus n minus 1D, right? So Tn, what is Tn here? That's what we're looking for, right? A is 4 plus n is n minus 1. D is 6. So Tn therefore becomes 4 plus 6 times n, 6n minus 6 times 1, 6. 6 has opened that bracket. Then we have Tn equal to 6n plus 4 minus 6. I just rearranged so that Tn becomes 6n minus 2. So this is the nth term. Is that clear? This is the nth term. Now, how do I find the 100th term? Very simple. The T100 will be what? A plus 99D. Isn't it? I mean, I hope you already understand how I'm generating that, okay? So, T100 will be equal to, what is A? A is 4. So, we have 4 plus 99 times 6, okay? So, equals 4 plus 99 times 6. That's going to give us 549 and 594 because 100 times 6 is 600 minus 6. So 594. Am I correct? 100 times, yes, I'm correct. So here it becomes what? T100 becomes what? 4 times this guy, 4 plus this guy, that is 598. All right. So this will be the answer, 598. Then let's now solve the E question. It said, find the sum of the first 100 terms. The sum of the first 100 terms. Then if you need other questions, more questions, you can still reach out to me on the WhatsApp line. Sum of the first 100 terms. What is S100? That's what we're told to look for, right? So since we already know the 100 term, so we can easily use n over 2 into bracket a plus l, isn't it? So S100 becomes n over 2. What is n? That is 100, sorry. 100 over 2 into bracket a, which is 4. Plus what's the last term? 598. Right, so that S100 becomes 50 into bracket 4 plus 598. That gives you 602. So 602 times 50. S100 equals 602 times 50. That is 60200 over 2. That is 30100. All right. What I did here was just, I multiplied this guy by 2 to give me 100. I now use 100 to multiply it because it's easier. So I'll now divide the answer by 2. Use your calculator, you get the same answer. So now let's go to number 3. Number 3 says, the 5th term and 10th terms are 0 and 10. I just go 5th term a plus 4d, 10th term a plus 9d are 0 and 10. Like that. This is where I interpreted the question very easily. All right, so the next thing we'll now do is take subtract equation this from this. So when you subtract, okay, let's subtract equation 1 now from 2 to still give us 0 for this side. Then this minus this will give us, that is, we are subtracting this from this, that will be this minus this. That is 5d equal to this minus this, 10. So from here, D will be equal to what? 2, isn't it? That's how you divide both sides by 5. So recall that A plus 4D is 0 in equation 1. So and D is now 2. So A plus 8 is 0, right? So that A will be equal to minus 8. And this makes sense because if your fifth term is 0, if your fifth term is 0, then you are coming from negative. Is that clear? All right. So the 20th term is what we are now asked to find. What will 20th term be? T20 is what? A plus 19D. Very simple. So equal to minus 8 plus 19D. So what is D? Sorry. D is 2. So times 2. That will be minus 8 plus 38. That is 38 minus 8, which is what? 30. So this will be the 20th term. All right. I hope this is clear. Now let's go to number 4. Find the values of x and y in the arithmetic progression. Let me see if I can squeeze it in here. So I'm playing number 3 and the other one. It says we should find the value of x and y in this progression, number 4. The progression minus 12x. All right, so please, excuse me, my microphone went off. So I'll just explain what I did here again. I did the first term is this, and the fourth term is going to be a plus 3d, right? So a plus 3d will be equal to 18, which is the fourth term. 1, 2, 3, 4, right? That's the fourth term. So by the time you substitute for a here, you have minus 12 plus 3d equal to 18. So make 3d subject so that this guy goes there, and you have d to be 10. So second term will be x, isn't it? And the expression for second term is a plus d. So that will be a plus d here. So x is a plus d, so that you have a, which is minus 12 here, plus the d you just got, will give you this. Then to get the next term, which is y, just add your common difference plus the term you got here. That will be minus 2 plus 10, and that is 8. So that's it. My microphone went off. So let's go to GP. Let me quickly explain what GP is. Now, GP stands for geometric progression, okay? It's the opposite of arithmetic progression. Geometric progression. It's another form of sequence and series. So the series of this is going to be the sum of geometric sequence. Is that okay? The sum of geometric sequence will be the geometric series. Now, the same way we did for AP, let us obtain an expression for GP as well. Let's obtain an expression for GP. So what would the expression look like? The first step, let's first get, let's use an hypothetical example. 2, let's say our sequence is 2 times 3. Let's say 2. So multiply by 3 is 6, multiply by 3 is 18 by 3. 18 by 3, 2 is 36, so 3 will be 54. By 3 also, 132. So let's stop here. Now, you see this guy? Let's say this 162, sorry, 162. So let's say this is our GP. Okay, this is our geometric progression. Now, how do we obtain an expression for it? The same way. In this case, I still like to use terms. Okay, I like to use terms. But your textbook might use U or something. I just like T. So I'll stick with my T. T1 is my first term here, which is 2, right? Now, how did I get T2 here? You notice that I multiplied 2 by a particular number. I multiplied 2 by 3, isn't it? By multiplying 2 by 3, I told you here that there's a relationship between there will be multiplication and division, right? So, 2 by 3 here, the operations used rather, addition, multiplication and division. So 2 by 3 here will what give me 6. How about T3 here? T3 is going to be 6 times 3. But 6 is already 2 times 3, right? Then I now multiply that again by 3 will give me 18, isn't it? Right? So how about T4? T4 is basically this guy, right? Which is 18 times 3 again, right? So that will be 2 times 3, which is 18, right? Then times another 3 will give me 54, right? Good. Following this, I can make an expression here that if I use that my first term, let's call it A, let's call my first term A, that my second term can be gotten by multiplying my A by a particular number here. Now, this one is not a difference, so I like to call it R. But keep in mind that R has a name. The R is actually called common ratio, and I'll tell you how to come about it. But let's first stick to R now. Just know it as R for now. Now, T3 is going to be my first term is still appearing again, times my ratio again, times my ratio. T4 here was gotten by the first term times ratio, times ratio, times ratio. By the time we write an expression for this becomes A times R raised to power, there's no R here. Because since there's no R, it means R is raised to power 0, isn't it? Here it will be AR raised to power 1, right? For T3, it is AR raised to power 2, right? For T4, it will be AR raised to power 3. What are you noticing? You're noticing the same thing, that if it were T5 now, it will become what? AR raised to power 4. Because you are seeing that it's as though any term I'm looking for, if I'm looking for an nth term, I should multiply my first term times the ratio raised to power that number minus 1. So this is the equation for GP. This is the expression for finding a particular term in GP. Is that clear? So usually this will also be the last term. Do you understand now? So the nth term of GP is given by AR raised to power n minus 1. What is that R? How do we get our R here? How do we get this 3 here? It is by dividing into consecutive terms like this. So it will be T2 over T1. It will give me the same thing as T3 over T2. It will give me the same thing as T4 over T3 like this. What is T2 over T1? That's 6 over 2. It's the same as 18 over 3. 18 over 6 rather, the same as 54 over 18. So you are seeing that it's going to give me exactly the same answer, which is 3. Do you understand now? So that is how to get common ratio. The number in front, the term in front divided by the term before it. Is that clear? Alright. How do we now get series of GP, sum of GP? Now let's create an expression for sum of GP as well now. You're going to see it's simple, it's not as hard as you think. Jesus Christ. I didn't answer the question here. So please, you should answer the question. It's because that microphone messed up. I forgot. I'm sorry. Now, for sum of GP now. Sum of GP. Now, what is sum of GP going to look like? Now, look at me. If I want to add up all of this my expression, the sum will look like this. The first term, which is A raised to power 0 is A, right? So A plus the second term, which is AR raised to power 1 or AR plus A raised to power 2 plus AR raised to power 3 plus AR raised to power 4 plus, you can continue like that up until we get to AR raised to power n minus 1. Is that clear? Now, look at something that I want to show you something now. What is the next step we can get here? That is ahead here. What's the next step that we can get ahead there? The next step we can get there, it can be gotten. If I want to shift this sequence, this sequence, a term ahead, this progression, a term ahead, I'll just multiply this sum by my R. Because to get this term is just multiplying this guy by R. To get this term, multiply this guy by R. To get this term, multiply this guy by R. To get this term, multiply this guy by R. You understand? So to shift it forward by 1, what do? I multiply my sequence, my sum, by multiply by 1. It will become this one by 1, by R, multiplied by R becomes AR. This guy by R becomes AR squared. This guy multiplied by R becomes AR cubed. This guy multiplied by R, AR to the 4th. This guy multiplied by R is AR to the 5th, isn't it? So by the time I do that, I'm going to get up to this place
A raised by n minus 1. Then, if I multiply this guy by 1, I will get, I'll still get up to this place, right? If I now multiply this guy by 1, I'll get AR raised to power, plus AR raised to power n. Exactly. Because you see that what I am getting is just the forward terms, right? The forward terms. The forward terms. So this one will be ahead somewhere. If I continue to eternity, this one will be ahead somewhere. And this one will be the next term ahead of this one, after this one. Now multiply this guy by 1. Let's do it together. By r. AR raised to power n minus 1 times r. This becomes AR raised to power n over divided by r raised to power 1, right? If you don't understand, I've showed you why you need this textbook, okay? Foundation Maths. So divide by r, so multiplied by this r. This expression here is the same as this. Exactly. So this becomes AR raised to power n over r times r. This takes care of this and we have this. Is it clear now? Do you understand now? So that is, I want to show you how the formula for sum of GP is derived, okay? Now, what I have here, then I can do something. I can either subtract equation 1 from equation 2, let's call this equation 1, let's call this equation 2, or equation 2 from equation 1, either ways. But I like to do this one from this one. I want to subtract equation 1 from equation 2. So that will become Rs sub n minus S sub n will give me, now, A minus, there is nothing here, right? So that will be A itself plus, if I subtract this from this, it will give me 0, isn't it? If I subtract this from this, it will give me 0 again. This from this, 0 again. This from this, 0 again, isn't it? Now, watch carefully. What if I now subtract? Now, looking at this, if I go a term higher here, I will have another term that is equal to this. So this one will also leave. Do you understand? If I just go a step higher. Now, also, this one, we cancel this one. So it will be A plus this one that is remaining here because there's no other term here in front. So because this is the last guy here. So AR raised to power n, okay? I would have shown you the trick here too, but just understand what I'm explaining. So S sub n is common between r minus 1, right? If you open this bracket, you get this back, right? Is equal to A is common between 1 plus r. No, I'm sorry. We are doing minus, right? I wanted to show you this, I'm sorry. And take note of the fact that it is every term plus this minus this, this minus this, this minus this, this minus this, and nothing minus this. Is that okay? So it should be minus here, not plus. I hope you understand what I mean. It should be minus here. Because it is, how are we doing it? We are doing this minus this, right? So it is this minus A. If we do it that way, just watch it. It will give me the same expression. That will be this minus the top, right? This minus the top. So this minus nothing here minus A. Then plus nothing here. This minus this, this minus this, this minus this, this minus this, this minus somewhere something here that is ahead. Then this minus this 0. Then this AR square n minus nothing. Is that okay? So nothing goes, exactly. So that this expression becomes, we can write this as AR is by n minus A. In which case we'll be saying that S sub n into brackets R minus 1 becomes A is common between R is by n minus 1. Exactly. If you open the bracket, you get this back, right? So S sub n therefore becomes divide both sides by R minus 1 over R minus 1. S sub n becomes A into bracket Rn minus 1 over R minus 1. Now this is the formula if R is greater than 1. Is that clear? But if R were to be less than 1, reverse will be the case. And how do we get that? It's just by taking s minus this one. That will be s sub n minus r s sub n. That becomes this now, a minus this guy. Exactly, now a plus minus this guy. Exactly. So s sub n becomes 1 minus r equal to a into bracket 1 minus r to the n. Divide both sides by 1 minus r over 1 minus r, and we'll have s sub n equal to a into bracket 1 minus r over 1 minus r. So this is sum when r is less than 1. Is that clear? Now, how do we now take an infinite sum? So this is called sum to infinity. Sum to infinity. How do we take sum to infinity? So very easy, I'll just show you this, that s into sn equal to a into brackets 1 minus, when n is infinity now, n infinity. So that will be r raised to power infinity over 1 minus r. Now notice something, there's something you should know. That if I have a small number raised to power infinity, it will converge. If I have a big number raised to power infinity, it will diverge, right? So if I have something like this, since r is less than 1 here, 0. Let's say 2 raised to power, let's use a big number like 100. 0.2 raised to power 100, that thing will give me approximately 0. 0.2 raised to power 100 is giving me 1.26 times 10 to the power minus 70. Is that okay? Minus 70, that's 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 That will give me approximately 0. Is that okay? In fact, what I just said is already 0. So the function converges to undergo convergence. There is convergence of the sequence, so because of that, S infinity becomes A into bracket 1 minus 0 over 1 minus R. Okay, so S infinity becomes A times, this is 1 minus 0 is 1, A times 1, A over 1 minus R. Excuse me. All right, to wrap up the video, let's quickly solve the following question. It says, find the number of terms in the GP. These 5 plus 15. Now, when they write questions like this, you shouldn't be confused or get scared. It's just showing you that it is a series, okay? That is a series. It's taking sums. So I have to find the number of terms. This is the last term here. I remember that the last term we got it to what? A r raised by n minus 1. Using that expression that we did to before, what if we say, what is the fifth term? The fifth term was a r raised by what? 4. What is the 16th term? A r raised to power 15. Just be subtracting 1, right? What's the 100th term? A r raised to power 99. The same idea. Is that okay? So that's what we're going to use here still. So follow me. Like I said, he said we should find the number of terms here, right? Now, what's the first term here? A is already given to be 5. This is the first term. Is that clear? Now, our last term is already given also, but we can also find our R here from already. You notice that your R can be taken as 15 over 5 or 45 over 5. So 15 over 5 is what? 3. You see, you're already done, isn't it? So it's n we are looking for. So the number of terms. So we use this last term. Last term has been given to us as 1215 is equal to A, which is 5, times the common ratio, which is 3, raised to power n minus 1. Is this n we are looking for? Isn't it? So from here we can say that we can divide it by 5 here. 5 takes care of this here. 5. 5 here. We have 2. We have 2, 4, 1, 3. So we have 2, 4, 3 equal to 3 raised to power n minus 1. So from here already we can now, from here, What can we do here? You know that this expression, there are two things I can do, okay? Let me do the easiest one, which is to write them in common bases. 3, this guy can be written as a base of 3, so it becomes 3 raised to power, I think, 4. 3 times 3 is 9, 9 times 3 is 27, 27 times 3, 81. Okay, 81 times 3, that's 3 raised to power 5 is equal to 3 raised to power n minus 1. So since the bases are the same, the powers are the same, don't come cancelling this. You know, I've told you that before. So that's why you should buy that book. It will give you the steps and the right approach, okay, the correct approach. So don't cancel this. Since the bases are the same, the powers must be the same. That is 5 must be equal to n minus 1. 1 comes here, becomes 5 plus 1. So n equals 5 plus 1, which is what? 6. So the number of terms is 6. So that's that. Number 2 says find the sum of the GP. The sum of GP is Sn equal to A into bracket. All you have to check first is to know the formula you use. Is R greater than 1? If R is greater than 1, which in this case is greater than 1, you use R raised to power n minus 1 over R minus 1. If it's greater than 1, just know that the big one will be subtracting, 1 will be subtracted from the big one. But if it's smaller than 1, we'll be subtracting the small one from 1. Is that clear? So S of n becomes A, which is 5, into bracket, R, which is 3, raised to power n, which is 6. Some of the sum of the GP. Okay, yeah, there are six terms there. So 6 minus 1 all over R, which is 3 minus 1. So S sub n becomes 5 into bracket 3 raised to power 6. Now 3 raised to power 5 is 243. 243 times 3, that's 729. 729 minus 1 over 2. So it becomes 728 times 5. 5 times 728 all over 2. So one very easy thing we can do is cut here. It becomes 36 here, 4. So we have 5 times 3, 6, 4, which is equal to 3, 6, 4. Do the same thing I did the other time, divide by 2. Multiply this guy by 2, so we give us 10. 10 times this, then come and divide back by 2. Here is 18, so 20. The answer is 1820. And that's the answer. Exactly. So now number 2. Number 2. So this is I will solve here. This is I. Number 2 now. Number 2 has only one question. Number 2 says find the common ratio, the 6th term, and the sum of first 6 terms. Those are 3 questions in one. Our GP sequence looks like this: 1, 3a, and 9a squared. Okay, dot dot dot. So find that dot 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 means there are many more terms. Okay, there could be many more terms. So find the common ratio. Common ratio is given by, just take T2 over T1, right? So that will be 3a over 1, which is what? 3a. In which case, if you still do this over this, you get 3a. Exactly. I mean the same way, rather. Then the 6th term, that's T6 now, will be equal to what? A raised to power what? R raised to power what? 5. T6 will be A raised to power 5. T7, R raised to power 6. T19, A raised to power 18. Is that correct? So that's the approach I use there. So to find T6, we already know A, which is 1 times R is 3A. So R raised to power 5. 3A raised to power 5. So T6 becomes 1 times 3 raised to power 5 is 243. That will be 243 A raised to power 5. Exactly. Okay, we're not even done yet. This is the first question, the second question, then the third question says the sum of the first 6 terms. So the sum S6 will become A is 3A. So we are assuming that it is greater than 1, right? So it becomes A into bracket, we're using this R minus 1, R over R minus 1. So S6 becomes A, which is 1 into bracket R, which is 3A, R raised to power 6, then minus 1 here over 3A minus 1. Okay? So this becomes 3a, S6 becomes 3a raised to the power 6. That's 3 raised to the power 6 times 3 raised to the power 6. That'll be 729 from what we did just now. 729 a raised to the power 6 minus 1 all over 3a minus 1. What more can we do here? There's really nothing much we can do. Well, except if we want to from here, there's nothing much we can do here. If we express this as 3a raised to the power 3, 3a raised to the power 3 all squared minus 1 squared. So it becomes difference of 2 squared, so it becomes 3 raised to the power 3 minus 1 times 3 raised to the power 3 plus 1. It doesn't change anything, so let's leave it that way. So this becomes our answer. Now number 3 says we should calculate the sum to infinity, sum of infinite series. We have 1 minus 1 over 2 plus 1 over 4 minus ... Now this should not also confuse you. Just take each term singly. This first term, second term, third term. So to get the common ratio here, first, what's the first term here is 1. Common ratio here, just take any two consecutive terms. Have 1 over 4 divided by minus 1 over 2. Or minus 1 over 2 divided by 1. You get the same answer. So R becomes 1 over 4 times minus 2 over 1. You get here 1, here 2. So you see R equals to still minus 1 over 2. So if you are taking minus 1 over 2 divided by 1, you still get minus 1 over 2. Alright. So it says to find sum to infinity. And S infinity is A over 1 minus R. So S infinity therefore becomes A, which is 1 over 1 minus, what is R here? Minus half. So S infinity becomes 1 over 1 plus half. So that becomes 1 and a half, which is 3 over 2. So 2 will go up. S infinity becomes 2 over 3. So, and that will be the answer here. Then number 4. Number 4 says that a GP has a common ratio of 3. So R is 3. If the difference between the first, so A, first term, and fifth term is 160, so that will be positive difference. What is first term is A. What is T5 is A raised to power AR raised to power 4. Is that clear? So the difference between them, that is AR raised to power 4 minus A is what? Is 160. This is how to interpret it. Is that clear? Now, I've gotten common ratio to be 3. Then this thing is easy. So it becomes A into bracket R raised to power 4 minus 1 equal to 160. So that becomes A into bracket. What is R? R is already 3. 3 raised to power 4 minus 1 equals 160. So it becomes A into bracket. 3 raised to power 4 is 81 because that is 243. So that's 81 minus 1 equals 160. So it becomes A into bracket 80 equals 160. Divide that by 80. A equals 2. Is that clear? So find what? The fifth term. What's the fifth term? So T5 is what already AR raised to power 4, right? So AR raised to power 4 will just be, or T5 will just be, what is A? 2 times R raised to power 4 gave us 81, right? 2 times 81. So T5 will be equal to 162. Alright. So that's that. You see how easy that is? Then number 5. Number 5 question says, the second and fifth term. I'm trying to, so that I will solve everything here. The second and fifth term of a GP. What's the second term of the GP? AR. Makes sense that AR is power 1, right? The second and the fifth term is AR is power 4. Is that clear? So what the second term is 2 over 3, and the fifth term is 1 over 12, respectively. The first term is what? What is A? That's what we're looking for. So when you have something like this, just take the ratio. So divide equation 1, this is equation 1, this is equation 2. Divide equation 1 by 2, it becomes AR. If you divide equation 2 by 1, it will even be easier. So it's the same thing, it's the same thing, okay? Divide equation 2, let's even do it that way, it's easier. Equation 2 over equation 1. But you get the same answer, so in as much as you solve it the same way. So we have a raised to power 4 equal to 1 over 2, that's equation 1, equation 2, over AR here over 2 over 3. Is that clear? So here, A can take care of A. This becomes R raised to power 4 divided by R is equal to 1 over 12 divided by 2 over 3. This becomes R raised to power 4 minus 1, that is R raised to power 3, equal to 1 over 12 times 3 over 2. Here 1, here 4. So R raised to power 3 becomes 1 over 4 times 2, that is 8. 1 over 8. So R raised to power 3 becomes 1 over 2 becomes 1 over 8 becomes 2 raised to power minus 3. Because 1 over 8 is 1 over 2 raised to power 3, which is the same as 2 raised to power minus 3. So from here, we'll say that we'll try to equate it. Or we'll just do this way, see. 1 over 2 raised to power, 1 over 2 raised to power 3. Do you see that now? So the powers are the same, so the bases must be the same. So that R therefore is what? Minus, R therefore becomes what? 1 over 2. So that is R. But it says you find A, right? So from equation 1, we know that AR is 2 over 3, isn't it? So we'll now take R as subject, we already know what R is. So A times 1 over 2, right? That's R is equal to 2 over 3. So multiply both sides by 2. If we multiply both sides by 2, it will remain only A here, equals 2 times this, 2 times 4. That is 2 times 2, 4 over 3. That is our A. Is that clear? Good. Then number 6 will now become number 6 question. Let's solve it here. Number 6 question says that the sum of the first 2 terms of a GP is P. The sum of the first 2 terms of a GP. So the first 2 terms of a GP. So what will be the first term is A, second term AR. So the sum of those first 2 terms is P. So A plus AR is P. Is that clear? And the sum of the last 2 terms is Q. Okay? So what will be the last 2 terms? So the last 2 terms, the last term, what's the formula for last term first? Last term is AR raised to power n minus 1, right? So the term before it will be, so the sum, this is the last term, right? Then the term before it will be AR raised to power n minus 2. Do you agree? Because the term before it will just be a term away from here. If this one is raised to power minus 1, then this one will be minus 2. I hope you understand. That is, if I'm dividing by a ratio of R raised to power 1 here, then I'll be dividing by R raised to power 2 here. If there is a term before it. Is that clear? So the last 2 terms will be this. Their sum is Q. Okay? So if this is equation 1, what does it say we should find? If the GP has n terms, the common ratio is, so we're just looking for an expression for R. N is n. Okay, so let's just simplify. From equation 1, we have that A into bracket 1 plus R, isn't it? Okay, is equal to P. And for equation 2, what is common here? What is common? A is common. Let's first do A. A into bracket R is by n minus 1 plus R is by n minus 2 equal to Q. What can we do from here? Let's solve this one here, this expression here. Let's simplify it further. This expression here becomes R is by n minus 1 plus R is by n minus 2. This one can be written as R is by n over R, right? Plus this one becomes R is by n minus R squared. right? So if that's the case, I can say that r raised by n is common. No, how do I simplify it? How do I write an expression for r? Let's see, if we make LCM r squared, this r times that becomes r raised by n plus 1. Okay, plus r raised by n. Okay. R in this r times this. Okay, so what can we do from here? We are looking for the common ratio, the expression for the common ratio. R raised by n plus 1 over r squared. Okay, so from here, okay, you notice that here, do you notice something? That this thing means r raised by n times r plus r raised by n all over r squared, right? Okay, this is my r, right? It looks somehow r. So from here, I can factorize r raised by n out. It will remain r here plus 1 over r squared. I think something is coming out now. Let's bring this into the equation. So let's bring it back. What we had was a into brackets. Let's write this in opposite way so that it will be 1 plus r. Or yes, let's make it 1 plus, let's make this one r plus 1. R plus 1 is the same, right? It's the same. Equal to p. Then q now becomes a into brackets r raised by n into brackets r plus 1 over r squared. Okay, I thought it would change something. What will common ratio be? Okay, so what we'll do is let's take the ratio of both expressions. So it becomes p over q. Yes, divide equation 1, this is equation 1, this is equation 2. Divide equation 1 by 2. It becomes this takes care of this, so that p over q will be equal to r plus 1 divided by r raised by n r plus 1 over r squared, isn't it? So r squared can come up, isn't it? So it becomes, this becomes p over q, which is now equal to r plus 1 times r squared all over r raised by n times r plus 1. R plus 1 can cancel r plus 1. We're getting somewhere. So let's be sure first. This guy goes here. Yes. So p over q therefore becomes r squared. We're looking for r. I want to make r subject. Okay, so from here, okay, let's write this as a common number, as a common base. This becomes p over q equals r raised by n 2 minus n. Is that clear? So if this be the case, what do we have? How can we make r subject of the formula? R can become the subject of the formula by doing the following. Now look at this thing. See, you recall that if I have something like this in indices, a raised to power x, for example, if I take it as 5, if I take it as a particular n, I can take it as like this, that a raised by x times 1 over x is equal to m raised by 1 over x. So this takes care of this, so that a will be equal to m raised by 1 over x. This expression is the same as this expression. Do you know what I did? I basically multiplied by the power so that I can neutralize that power there. So from here, since I have p over q to be equal to r raised to power 2 minus n, and I can multiply here by 2 minus 1 over 2 minus n. Multiply both sides by 1 over 2 minus n. I'll multiply here too by 1 over 2 minus n. So that this takes care of this, and r becomes p over q raised to power 1 over 2 minus n. This will be the expression for the r. That will be it for the video. Do well to subscribe to the channel and click the bell notification to get notified whenever I drop a new video and get your textbook. Reach me out on that number and I'll send you the number of the writer of the book. So please subscribe to the channel. God bless you.